Shall start? Okay, anyway, I'm just trying to. If I get time, I thought I can do this work also. It is installing the retext package. It is installing. I'm not getting it. No, actually, see, R Studio is another appendage. Oh, so you got only R Studio with you. R, it's an additional package. So don't worry about that, right? Of course, R Studio is very good, right? In certain sense. But raw R also can do many things, right? Okay. In this regard, I'll just tell you two things. One, R can be driven with two things. One, this R console. R console can be used to drive R, right? Another option is also there. This is R editor, right? So you have script editor, right? This is bunch code operator, right? Bunch code means instead of running the R codes individually, you can run them in mass, right? So after writing a code, a bunch of codes, you can run them together, right? This bunch codes can also be simultaneously run, right? So in both ways, R can be controlled, right? One with this R console, the other one is R script editor, right? So what is the advantage of this one? Actually, this R console will run one by one. Even if you copy paste the entire 100 line code, it will run one by one, right? No problem. You can paste it, you can run it. But this one, you can see, right? You can see the codes. And if it is not visible, I'll just show you in the Word. Okay. So this is the code. This is the code, right? Good, thing about this bunch code running is you can check whether which line creates problem. Which line creates problem, right? You can run it one by one sometimes, right? Till it doesn't show a error, we can confirm there is no problem in the codes, right? If some line creates problem, we can identify problem with that. If any error message comes, we can copy paste in the chat GPT and solve our problem, right? It will show sometimes this function is not available, this object is not available, right? This error in the argument, all those things that will mention, right? You can identify and solve the problems accordingly. If it is saying the function is not available, then you have to check for the package, right? You have to go to the package and see whether the function is available in the package. You have to see whether the package is loaded. Three things. If it says some function is not available, there could be three problems. One, the package is not, may not be available in your R. In that case, you have to install R. Sometimes you would have installed the package, but you wouldn't have loaded the package, right? Sometimes you would have loaded the package, but the functions may not be, you might not have mentioned it correctly. Actually, I'll just show you one example. Actually, in fact, today morning I had the problem, right? I was running one function, rcout function, right? It was mentioning the function is not available. Then I went to the documentation of that particular package. There I saw the function is little different. It was Kochiran.rcout, that function, right? In that case, the function is not rcout, right? The function was Kochiran.rcout, right? When I mentioned that, it was running nicely, right? So three things, right? If it is showing an error, one, if it is saying the function is not available, your R may not have the package installed, the R may not have loaded the package, or the function might not have, actually you would have named the function, right? So these are all the problems, right? Otherwise, if the function is not the problem, if it is saying something else, you have to look into that and you have to correct it. What could be the right problem? Your the argument might not be correct, right? You would not have mentioned the data files correctly, right? Maybe the problem. Okay. Now you all have the packages with you. This files with you, data files with you, right? You have the files.
We have RStudio installed already.
Okay, fine. Actually, I'm not using RStudio at all. R console only. I'm just going straight to the R console and batch files, right? I'm very comfortable using this R console and this one, batch file, right? It will look very simple, you can run it, right? Of course, it has got its own advantage. R console has got its own advantage, but this is very simple, right? Okay. Yeah. Could you see this? Interesting. Yeah. Is it okay? Is it okay now? Is it okay now? You have the data XLSX, right? In that you have MLRM file, right? Actually, one sheet is named MLRM, right? You can open it and you can save as .csv file in the same name, right? In the same name, you can save it as MLRM.csv.
Make it a little more bigger.
Is it fine now? Is it okay now? Fine. Okay, this thing is very important. Location of the file. Location of the file. Actually, you can save it anywhere. Don't worry. You can save it anywhere. But you need to know the path of it. Okay? You need to know the path of it. How would you know the path? Usually, I'll save all my files in desktop. Right? People sometimes curse me. Right? Don't keep everything in the desktop, but it is very easy for me to work, right? Okay. Now I have, where is my data? Okay, I have saved it here, MLRM, right? It is here, right? I need to know the path of it. How would I know? Right click, properties, right? Go to properties. Yeah, it is there. Location. This is the path.
You mentioned that Control C.
Huh?
Use Control C. Mention.
Yeah.
Please mention.
Yeah, okay. You have to copy it. Control C. After selecting it, right? Copy C. Control C. Now, so this is the path, right? There is a convention in mentioning the path in R, right? This is a very distinct thing, right? This is the very conventional way of mentioning path in Windows, but in R the convention is little different, right? Either you should not use the backslash, you have to use the front slash. Otherwise, if you are not comfortable with that, double slash, double backslash. Okay, this is the path. Then file name. CSV. Right? This is the path. Fine. This is how you should define a path name in R. Right? Two things. Single backslash is not a convention in R. It will not take the file path. Right? It will not take that as a file path. Either you have to use the front slash or double backslash. Okay? So you have to do that. Then you have to say whether it is a data frame. If it's a data frame, it will have the caption in the first line. It has to be specified there, right? So second important specification is, after mentioning the path, important mentioning is header equal to true. Means the file has got a header, caption, right? That's it. Could you read it? Any error coming? If error comes, don't worry, don't get frightened, be happy, because it is a lesson, right? It teaches you, right, you are wrong, right? If you are getting any error, copy the error, paste it in ChatGPT, it will give you the answer, right? How to correct, right? Any error coming? Have any problem?
Showing the screen.
Which error? Which? Pause. Okay, fine. I am going to run it. Okay, I am going to run the first line. Select that line. Okay, I have selected that line, right? I am going to run it. Select the line, just press Ctrl R. Otherwise, run line. Run line or selection. Otherwise, right click, show you. It will show you the menu. Right? Otherwise, simply Ctrl R.
Please resize that window. This
Ah,
console window.
ah.
Resize. I'm not fully that resize.
Resize means actually,
Actually, you minimize restore. Restore. Middle. Middle, restore. Then the end there, that corner. You know,
oh, wait.
right.
Right?
That, you can resize up to that point. For that.
Okay, yeah. Both. Huh? We can read both.
Okay, right, exactly. The corner.
Yes.
So whether we can zoom the console window, whether the
Yeah, we can. Actually, sometimes we have some problems. Some certain windows will not show. But here it is it is increasing. The size is increased. Let me see. We are not size is not going up. I could not increase the size. Okay. 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 Santosh, do you have the mouse?
yeah.
I've got some problem.
Yeah, I'll see. Console, whether we can increase console.
It does not. The size was not increasing. It's trying to. But no problem. Actually, we can paste it in the Word and we can show them. Yeah.
It's coming.
Yeah.
Now it is almost okay. You can show both the windows together,
Okay.
console and editor.
We'll write it and we'll show it. Yeah. Okay, first I'll read the data, okay? I'll run. It is done. Without error, it is done, right? It is stored in data file, actual data. I named it data. The data frame is named data, okay? I named it data, right? I want to see the content of it, right? I want to see the content of it. What is the content? Actually, we'll show to the, we will go to the MLRM file. So this is the file, okay? This is the file. This is the file. First column year, second column GDP, third column employment, fourth column fixed underscore capital, right? So this is the file. We can see whether this data is got into R. How do you do it? You can check whether the things are gone into this data. It is not increasing, that is the problem. Huh? So it is there. The data is got into R. We can check whether data is there in R. Fine? Okay. Now what next? You can do simple regression model. Right? What is the function for simple regression model? Simple regression model, how do you type? What is the function for running a regression model? LM. Okay. LM is the function. I'll show you, right, how the LM function will look like. Okay. So this is the LM function, okay? For fitting a linear model, we will use a function called LM. This is available in your base package. So for this, you need not have to install any special package, right? Okay. What should you give? You have to give two things. One, LM is the function call, right? Bracket, you have to give the regression model. Very simple regression model. Left hand side you have to give the dependent variable. Right hand side you have to give the independent variables list separated by plus. List of independent variables separated by plus. Get this point clear? List of separate independent variables separated by list, right? For equal to symbol, you have to put tilde, right? Okay, in this case, you have to write. How do you write? You are running the MLRM, right? How do you type? First, we'll type it and then we'll paste it in the script editor. LM, all small letter only. LM, what would you write? What is the dependent variable here? What is the dependent variable? So actually this is nothing but a production function. It's nothing but a production function, linear production function, right? GDP as a function of labor and capital. GDP as a function of labor and capital. So GDP is the dependent variable. All GDP, tilde equal to, right? You have to put the independent variables list, right? What is the independent variable? Fixed capital, right? plus employment, right? 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 You have to check, it is for the case sensitivity. Yeah, it is there. Employment. If you have this problem, name everything x1, x2, x3, y like that. Right? Okay. Now we have written for this one. We will name this as one model. Right? Usually this is the regression model. Right? This can be named as one object. Right? We'll call it model. Right? Why should you have to do? Because only if you define that as a object can you display it. Otherwise, you have to write everything again. Right? Okay. So now I am going to run this line. Run this command. Either you can paste straight away. Right? Some yeah. What is the problem? You have not attached the file. You have not attached the file, right? First, let me attach. Attach data. Otherwise, I have to say it is not data. It is done. No problem. Right? Now, how would you see the results? Summary. I got the problem. It's very.
Any option is there in the view menu
Ah.
increase the size of
No, not possible. Not possible. We will do actually. We'll just paste the word. It's summary model. Base package. I'll just paste it in the word and show you, and I'll explain, right? Just look at this. Right? After importing the data as data, right? Data is the data frame, right? Containing data on GDP, employment, and fixed capital, right? Now, I have run the regression model. I saved the regression model as model, right? Now I am displaying the summary of the model, right? Now it is showing up the results, right? Just look at that. We'll reduce the size, only then can you really get the correct representation, okay? Yeah. This is value. This is standard error. This is t value. This is p value. Right, to distinguish it. Ah.
please show the previous page so that we can see the command line.
Ah,
Scroll up. Otherwise,
could you see this? How did I write? How did I write? LM is the function for regression model. Specify dependent variable and independent variables. What is the dependent variable here? GDP. That is the output. That is the output, right? GDP is the output, right? And what are the inputs? Fixed capital and employment, labor, capital and labor, right? So you list them separated by plus, separated by plus. In between, for equivalent symbol, equal to symbol, you are putting tilde. You are putting tilde, right? So this is a very simple function. Fine. Then put summary of the model. What is this model? You said the regression model as model. You named it model. You named it model. Otherwise, you can put it LPF, linear production function. LPF. You can name it LPF also.
can you please once again explain? Starting from up to the last day, we work with the R Studio.
Okay, fine.
So people are using R Studio, but I think
No, even in R Studio, you can use this.
it's better we practice our consoles.
Okay, fine.
So once again, you
Yeah. See, first you are importing data. First part. Second part, after importing the data, you are checking whether data has come into R. How do you do it? You are naming the data frame as data. Data frame as data. Right? So where is it? I'll just show the command for that. This is the data.
all the commands one time. Then they will type that in the R console.
Okay. Right? This is the command used to import data. How did you import data in our the studio? How did you do it?
Directly from by using file.
Okay.
Read CSV.
Okay.
I actually by using the menu.
Okay, menu. So it was like driven.
The menu option is also there.
Okay. Now you have to write read.csv. That's it. Nothing else. Right? Afterwards, you are giving the data path. Right? So two arguments you have to give. To import the data, you have to give two arguments. What are all they? One, data file path. Then you have to say whether the data file has got a header or not. Only two arguments. File path and confirming the header. Right? Only two arguments. Right? So this is the first argument. This is the first argument. Right? Otherwise, we could have used RStudio also.
I think we we need to understand the procedures in our console also. Our console is very easy. Our studio is another version. We can use our studio also, there is no problem. But our console is so straight and so simple. So we need to learn how to take all these things in our console itself. So do all these procedures in our console. Because these are the commands that we have to just type it. And the same thing we can do in our studio also. That's ചെയ്യാൻ കുറച്ചുകൂടെ എളുപ്പമാണ്. അതെങ്കിൽ ഫോൺ നേരെ വർക്കായിക്കോളും. പ്രശ്നമാണ് നമുക്ക് മെയിനായിട്ട് ചെയ്യേണ്ടത് അല്ലേ? മെയിനായി നമുക്ക് പ്രശ്നമാണ് ചെയ്യേണ്ടത്. ഡിസ്ക്രിപ്റ്റീവ്സ് നമുക്ക് നോക്കാം.
Yeah, don't worry. See, I just used ChatGPT to generate the code, right? It has generated the code. Fine. I just copy it. I'll paste it. ChatGPT has given the code. So the first part, the green part, is the file path. Second part is the confirming the first line. Here there is no first line, right? In our case, we have got a first line, so we put capital true, TRUE, all capitals, right? Header equal to true. So only two arguments you have to give for inputting the data, right? So I used it to get the data into R. Fine? Okay? Right? Could you generate this file path? Could you generate the file path? Right? So okay, fine, that's it. Right? Now run it. Were you able to run it? I'm saving that in a different name. I'm naming the data. What is the name I'm giving? Data. Data is the name given for this data frame. Right? MLRM data frame, I'm giving a name. Right? Otherwise you can put a MLRM also. You can give any name. Right? So once it is done, you attach the data. Now you create a model. Regression model. Right? How would you write the regression model? What is the argument you have to give? You have to give dependent variable. You have to give independent variables separated by plus. Right? Instead of equal to, you are putting tilde. That's it. Right? So this is it. This is a production function. We all know, right, how the data is constructed. GDP, fixed capital, employment. GDP, fixed capital, employment. Right? GDP is a function of capital and labor. Production function, linear production function. Right? Once it is done, you are writing the summary. Don't worry, just copy it. Type it anywhere. Right? Just copy it and paste it in the R console. Don't worry, just paste it in the R console. Result has come. Paste it in the R console. Control V. Get this point? You got the result? Okay. You try actually, if you get any, strip line. Importing data, attaching the data, then you are typing the model and giving the summary. What do you have to attach the data? Right? If you don't attach the data, you have to specify every time. Instead of GDP, you have to put data $GDP. This one, data dollar fixed capital. And for this data dollar, because the variables have to be mentioned with respect to its data frame. So first you have to mention data frame, then only you have to put the variable name. If you attach it, you don't need to do all this. If you attach the data, you need not have to do anything. Straight away you write the variable name. Get this point? Okay. So the result, is very simple. Actually, you can read the result very easily. It is like any other regression results. I'll copy and paste here. So this is the regression result. Regression result. It tells you everything. Okay, just look at that. What all does it show? This is the intercept value. This is the intercept value. This is the standard error. Actually, the thing is, okay, let me put that. I'll just type otherwise. Okay, just look at now. Now see that. This is like any other results. This is like any other result. Could you see this? Estimate, first column, right? Second column, standard error. Third column, t value. This is p value. Yeah. Look at this. This is standard error. This is t value. This is p value. Okay? Could you see this? This is the result. Estimate, standard error, t value and p value. Right? E minus 10 means 0.90. 0.90. Right? It is in the scientific format. It is in the scientific format. right? So all of them are significant at 5% level. All of them are significant at 5% level, right? What is this value? This is 0.05. So forget about this E value. Okay, this is scientific value and the normal value. This is four zeros, right, into this U can be removed, and this is the, right? Okay, so this is the value. This is the value. This is the marginal value, right? If you increase the fixed capital by 1 unit, on an average, the output will increase by 0.05 unit. Output will go by 0.05 unit, right? If you increase the labor by 1 unit, the output will go by 7.465 units, right? So this is how the value can be interpreted. This is the marginal values, right? This is the p value, right? Otherwise, what else is given in this one? R square is there, ANOVA values are there, F statistic, degrees of freedom 2, 17, P value, very small value, right? 16 zeros and 2 means very significant, right? So whatever value you get in EViews or no other things, you are getting everything. What are things you are getting? Coefficient value you are getting, right? The P value also you are getting. F value you are getting, and the P value also you are getting. Model specification parameters, right? And what else you are getting? You are getting R square value also. Fit of the model, right? So what is the fit? 0.9954, right? If you want, you can check it, right? Whether you are getting the same value in other softwares. You can check it with your Excel. You can check it with your Excel, right? Excel is very simple.
Can we get the ACT standard, HSC standard?
No, for that you have to go to the other specific function. Another function is there to get the HAC standard error. I'll show you that also, right? Okay. So this is how we will run any MLR, right? Do you want to check it with your Excel? You check it. Actually, the data is there, right? Check it with your softwares and come back. Tomorrow that can also be taken as one assignment, right? You can check it with the other softwares, right? If you have by eViews, if you have SPSS, Stata.
We do it with the Gujarati data.
Yeah, the same. This data file is available in Gujarati, right? Okay. What do I get in Gujarati? Actually, I think I got the results. Yeah, it is there, but it is in log form. Okay, now we'll see how to run that in log form. How to run this regression in log form. You can run it in the log form, right? We'll do it. What is the command you have to write for this log form? Okay, so this is the function, right? This is the function. Now you have to run this in the log form. Log of GDP. right? Log of fixed capital. Like in your reviews, there you have to put LN. This is natural logarithm only, right?
We need to change the name of the model.
Right? If you want to separate this, we can do it. Otherwise, it will override. It will override in the model, right? Right?
So then the summary also model.
Yeah, correct. Model one. Now we can run this also. We can paste it in the console. Result has come. Minus 1.65242, 0.84600. Yes.
So show once again that Kamaraj. I will convert file.
Yeah. Could you see this? What did I do? I just added log. Log, right? For each variable, I have put log command. It transforms the variable into log variable.
Without any additional procedure.
Yeah. We can compare.
This is the Gujarati result.
Yes. This is the Gujarati result. Just compare.
So, Pushparaj, please paste in another bed document
Ah,
so that we can compare that by
it's here.
that fits.
We'll we'll do other things. And to make it bigger, we'll do one more. Okay, so this is the Gujarati result, right? This is the Gujarati result. Now I am pasting the R result. Now you may compare. Could you compare this? Minus 1.6524, right? What do you get here? T value minus 2.7259. What is here? Minus 2.726. Right? The same. Could you compare this? This one is Gujarati result. Right? Taken from Gujarati book. This is the R result. Right? R square, how much? 0.9951. 0.9951. F value is not given here. It's not given here.
Side by side we know.
Not possible. Actually, it is given like this. This portrait. Sorry,
So this is
landscape.
The first one is the Gujarati result.
Yes, yes.
and the second also, they got the same one.
Yeah.
And here we got the 5 digits figure.
But actually, see, fine. You get the same. But the advantage of R is, far ahead. Actually, you see, you can do a lot of other things, right? After this, you can do a lot of. The result is same, no problem. But the capability, extends far beyond, right? That is the thing. Fine, fine with the MLRM. Then we will slowly move on to the other things, right? Okay. This, how do you how do you interpret the MLRM, right? MLRMs are interpreted in step by step. First, we will see, right, whether the model is distinctively different from your null model, right? Whether the model is valid at all, meaning you will interpret the F value, right? If the F value is significant, we will say the model is significantly different from null model, right? The first thing we have to interpret is the F value. Then we will see the fit of the model. We will see the fit of the model, right? First, it has to be significant. Only then you can move to the next, right? So next is fit, right? Fit can take the value between 0 and 1, right? R squared will take the value between 0 and 1. If it is 1, best fit. If it is 0, no fit, right? Then if the value is between this, the percentage of variation of y explained by this model, percentage of the outcome explained by this model, right, is interpreted as this R squared, right? If the R squared is 0.8, we'll say 80% of the variation in R is explained by this model, right? If it is 90%, right, the more the explanation capacity, good is the model, right? Better is the model, right? So the value will be between 0 and 1, right? The R square will tell you the percentage of variation explained by the model. The explanatory capacity of the model is assessed with R square, right? So the first F value will be interpreted, then the fit of the model or the explanation capacity of the model will be interpreted. Then we will interpret the individual T values, right? We will interpret the T values, right? How many variables significantly explain the outcome, right? Then we will explain the marginal values of those variables for which the coefficients are significant. We will explain the marginal values only for those variables for which the coefficients are significant. Here, all the variables are significant, right? All the variables are significant. So we can interpret the marginal values. How would you interpret the marginal values? This is the change in average outcome. Here in this case, average GDP. Change in average GDP. For every percentage change in variables, input variables, right? So this is the percentage change in GDP when there is a 1% change in fixed capital. This is the percentage change in GDP when there is a unit change in percentage change in employment, otherwise elasticity. It is a elasticity, right? Output elasticity of capital, output elasticity of employment, right? This is how it should be interpreted. Okay, this is the normal explanation, right, given for any regression model. This is how the results should be reported, right? Once the result is taken out from the software, the results have to be reported like this, right? The first line will indicate, right? You will put y hat, right? Dependent variable, you will put a hat on it. right? This explains the deterministic part of the model, right? The y hat means deterministic part of the regression model. If you don't put hat on it, you have to put u. At the end, you have to put plus u, right? If you don't want to use that plus u, remove it, put a hat on the dependent variable, right? So you put the dependent variable hat. That means the deterministic part of the model is explained, right? You put the coefficients, right? You just write the coefficients. This is the intercept, this is the coefficient of x2, coefficient of x3, coefficient of z. Right below it, usually people will give two things. One is either they would give standard error values or would they give t values, right? You have to report t values just below it, right? Here t values, this one is the t value of the intercept. This one is the t value of x2. This one is the t value of x3 coefficient. This is the t value of zt, right? Then you have to give the f value and degrees of freedom. Sometimes you have to report the degrees of freedom also, right? So f with degrees of freedom, then r square. This is how a regression model is reported, and the values of the model is interpreted this way. First you will interpret f, then you will interpret r square, then you will interpret t values, right? Then you will interpret the margin values when they are significant. This is how you would interpret. But this kind of interpretation model is not all the time correct, right? This type of interpretation of the model is not all the time correct, right? The models are estimated with some assumptions. 90. The models are interpreted, reported with some assumptions. What are the assumptions? Usual assumptions, or, right, we all know the OLS assumptions, right? The formula are derived for some, the formula given are derived based on some assumptions. What are the assumptions? The model does not have a autocorrelation. The model has a homoscedastic error, right? The model does not have the multicollinearity problem, right? So these are the assumptions, very common specification assumptions, right? If they are true, the interpretation is correct. Otherwise, this interpretation is not correct, right? So before interpreting it, you have to check whether the assumptions are satisfied. Right? We'll take the assumptions one by one. First prominent assumption is autocorrelation, right? We'll take the problem of autocorrelation first, right? You all know the academic part of it, but still, I'll just quickly go through the theory behind. What is autocorrelation? Correlation we all know. Autocorrelation, I usually know the correlation is defined for two different variables. But autocorrelation is defined for one single variable, right? One variable, right, taken at two different times. Right? So we call it autocorrelation, right? So correlation is a bivariate measure, but autocorrelation is a univariate measure, right? Actually, we know the lag values and the correlation between different lag values, right? There are different types of autocorrelation, first order and higher order correlations, right? First order means correlation between ut and ut minus 1, ut minus 1 and ut minus 2, right? The lag difference defines the order of correlation, right? So if it is between these two, lag order is defined as t minus 1, means 1, right? If the correlation is defined for ut and ut minus 2, This is second order autocorrelation. Right? Similarly, you can define higher order autocorrelation. Right? So the usual models, right? This wireless regression models assume there is no autocorrelation. Right? There is no autocorrelation. Right? Correlation to become a zero, if the covariation, right, is zero, the correlation will be zero. So the no correlation, no autocorrelation assumption is defined in terms of covariance, zero covariance between UT and higher order UTs, right? So the wireless assumption, right, assumes that the correlation, there is no correlation between UTs, right? Okay. Okay, so this is the covariance, right? This is the covariance. Usually this covariance is assumed to be zero. This covariance is assumed to be zero in the regression models. Based on that assumption only, the coefficients are derived. The formula for the different values are defined. What is the formula? Formula for estimating alpha, intercept, estimating beta, the slope, the standard error of alpha, the standard error of beta, right? So the formula for this is defined with this assumption in mind, right? If it is violated, what will be the consequence, right? The theory says, right, if that assumption is violated, the wireless estimators, right, will not be a problem, right, as they are unbiased, even with the presence of this problem, right? So it will not affect the estimation of the coefficients, mind you. The violation of wireless assumption of autocorrelation, right, will not affect the estimation of coefficients. What will be the impact? The impact will be felt on the estimation of standard errors of the coefficients. Standard error of the coefficients, right? I'll just show you quickly, right? So this is the variance. What is the standard error? Standard error is nothing but square root of the variance. Square root of the variance, right? Here in this case, this is the variance of the coefficient. Variance of the coefficient, right? So this is the actual formula for variance. The square root of it is known as standard error, right? If the wireless assumption is confirmed, or if we are confirmed that there is no correlation, this correlation term will become zero and this term will vanish. So this will represent the estimation of variance of the coefficient. Variance of the coefficient, right? So with the wireless assumption, this is the formula for variance of the coefficient. With the presence of autocorrelation, the formula for this becomes this, right? So the formula for estimating the variance of the coefficients is biased if the violation, the assumption is violated. If the assumption is violated, the formula becomes biased. It can take positive value and negative value. If the correlation is negative, right, this term can be negative. If the correlation is positive, this can be a positive value, mind you, right? So it can bias upwards or downwards. We don't know which way the value will go, right, if the assumption about the autocorrelation is violated, right? So either it can overestimate the variance and hence the standard error, or underestimate the standard error, right? So the t value cannot be interpreted correctly. It can be a value above it, or it can be a value below it, right? What would happen if the value is overestimated? In actuals, the value is not significant, but because of the overestimation of t value, it appears that the independent variable influences the output. In our case, right, output and the employment may not be in actuals related, but because of the overestimation of t value due to this autocorrelation problem, right, you are telling that employment has got a significant influence on output. Sometimes it will be underestimated, right? You would tell or you would infer that the employment is not influencing output, but in actuals it may be influencing, right, due to the autocorrelation problems, right? So the autocorrelation problem will affect the standard error estimation, right? As I told you, the formula is very different for with autocorrelation problem. Without autocorrelation problem, the formula will be very different. It may be overestimating the standard error or underestimating the standard error. Accordingly, your inference will be misleading, right? So it will mislead. What kind of impact would it have on the econometric analysis? As I told you, econometrics is about finding the confirming or verifying the theory, right? Cobb Douglas says the output is influenced only by capital and labor, right? Your production theory says output is influenced by theory, inputs. If it is not confirmed, if both the variables are not significant, right, your Cobb Douglas production theory is wrong, right? Sometimes if it is overestimated, right, even when the theory is wrong, you would say the theory is right, right? This is an error, right? If it is underestimated, even when it is right, you would infer it wrong. Get this point clear? So type 1 error, type 2 error, right? Error positive, error negative, right? Both the things are possible due to autocorrelation problem. So you have to be very careful when you are doing the econometric analysis, right? So you have to check for the autocorrelation problem, right? So this is the problem actually. I'll just quickly go through the implications of it. Actually, see, there are 5 implications, right? So variance of OLS estimators are underestimated in the presence of, or underestimated or overestimated in the presence of autocorrelation problem, right? That will influence t values, that will influence the R square sometimes, right? That will influence the interval estimators, right? The interval estimators are inefficient, will become inefficient when you are predicting or forecasting a value, right? Due to autocorrelation problem, right? So you have to test for the autocorrelation, right? Actually, there are multiple tests available, right, for checking the autocorrelation problem. Graphical methods are there, runs tests are there, chi-square, von Neumann, Durbin-Watson, Durbin-H, Bruce-Godfrey, right? Lot of tests are available, right? But we won't use all the tests to confirm the autocorrelation problem. There is a very time-tested or prominent test available, right? Actually, this Bruce Godfrey, right, is one such test, right? One such test, right? Quite often used, right? We all know Durbin also used, right? For all the other things, I have the codes with me, right? If anybody wants to check it, right? I have got the R code. Actually, we wrote all the codes, right? This is for graphical method, R codes, right? Run test also, so different tests are available. Forget about it, right? We will use only Godfrey, right? Godfrey test, Bruce Godfrey test, right? As I told you, this affects only the standard error, right? It doesn't affect the coefficient. It only affects the standard error, right? So there are procedures available to correct only the standard error, right? They will not go into the other things. They'll just rectify the standard error, right? If you correctly estimate the standard error, there ends the issue, right? So they are called robust standard errors, right? Robust means what? it will not, actually the errors that does not get influenced by the autocorrelation problem. Errors that does not get influenced by the standard error, right? If you could estimate the correct standard error, the problem of autocorrelation problem is solved, right? There are other procedures, some iterative procedures available, right? One such procedure is Cochrane-Arcourt, right? I'll teach you, right, how the Cochrane-Arcourt is done, right? What is the solution for this autocorrelation problem, right? I'll teach right after diagnosing the autocorrelation problem, we can solve the autocorrelation problem as I told you, right? One solution is this robust standard errors, right? So second solution is Cochrane-Arcourt iterative method. How would they do it? Right? They would do, first they'll run the regression, right? Usual regression will be run. Afterwards, you will find the error term. How would you find the error term? Very simple. You will have the equation, estimated equation. So this part will tell you the estimated output or y. This term will give the estimated output, right? That is yt hat. You have the actual yt, actual data, right? Subtract it, you will get the residual, right? So you will find the residual by simply subtracting the actual, estimated y from actual y, right? So this is the error term, right? So this residual, with this residual you can find the autocorrelation. You are just now seeing the error and its lag value, and you are seeing the correlation between ET hat and ET minus 1 hat. So this is the autocorrelation, right? After estimating the autocorrelation, you will do a small transformation of variables. You will do the transformation of variables. YT, right? XT also can be transformed, right? How would you transform? Each of the observations can be transformed, right? So it's very simple. For this program, instead of this is observation thing, we can straight away find the transformed variables. Yeah, this is the transformed variable. Get this point clear? You have yt and you have yt minus 1. Yt is the time variable. Lag variable is yt minus 1. You know the autocorrelation value, rho. How did you estimate the rho? This is how rho is estimated, right? Do the transformation, right? Yt minus rho yt minus 1. This is one variable. Another variable is xt minus rho xt minus 1, right? Two variables you are getting. Instead of running the regression model on yt on xt, yt on xt, you are running the transformed variable, right? Let me say this is yt star, this is yt star, this is xt star. You are running a regression model of yt on xt minus, xt star, right? Instead of running a simple regression, right, like this, you are running a regression of yt star on xt star, right? After running it, again you are testing, you are calculating this ET hat, right, and this rho hat, right? You are finding the another yt double star, xt double star, right? Like that you are doing the iteration. Up till what point would you do this iteration? you will do the iteration up till you are getting this row insignificant. You will run the model until you get the insignificant row. Means what? In that regression model, there is no autocorrelation. So you will do this iteration process until you get no autocorrelation problem, right? So you will take that standard error and that coefficient as the autocorrelation free regression model, right? This procedure is known as Cochran-Harcourt iterative procedure. Cochran-Harcourt iterative procedure, right? This can also be done with your R, right? This procedure is not available in any of the standard softwares, right? This is available in your R, right? So this can be done, right? So we are going to do only these three procedures, right? One is we are going to estimate the autocorrelation problem. We are going to estimate, test whether there is an autocorrelation problem with your Durbin-Watson. Of course, Durbin-Watson usually done like this, right? How would you do the Durbin-Watson test? Durbin-Watson test is done usually with this procedure. You will estimate the D value, Durbin-Watson, this is the formula for it, right? So this is how we will find the Durbin-Watson value, right? So this is the formula for it. So this is the formula for Durbin-Watson. After finding the D value, this is the calculated value, right? From the table, right, you have got in all the econometrics book, you have the Durbin-Watson table, right? You will be given two values, right? Durbin-Watson table will give you two values. One is DL and DU. Durbin-Watson lower bound, Durbin-Watson upper bound, right? Durbin-Watson lower bound, Durbin-Watson upper bound, right? Correspondingly, you can find 4 minus DU and 4 minus DL, right? This Durbin-Watson will take value between 0 and 4. Durbin-Watson will take value between 0 and 4, right? Why 0, 4? We know correlation will vary between -1 and +1. Usually correlation values will vary between -1 and +1. What is the relationship between Durbin-Watson and correlation value? This is the relationship, mind you. So this is the, just look at this. This is the relationship. So this is the relation, okay? Yeah. D is nothing but 2 into 1 minus rho hat. Rho is the autocorrelation, right? So rho can take value between -1 plus 1. If you put -1, what would you get? If you put -1, you get D equal to 4. If it is negative autocorrelation, perfect negative autocorrelation, D will be 4. If it is perfect positive autocorrelation, +1, what would you get? D is equal to 0. If there is no autocorrelation, right, what is the value? If you put rho equal to 0, D is 2. If D is 2, there is no autocorrelation. If D is 0, perfect negative autocorrelation. Perfect positive autocorrelation. If D is 4, perfect negative autocorrelation. So this is the range, right? So this is the range. Get you? So this is the range. This is the range. It takes the value between 0 and 4. 0 and 4. Right? This Durbin statistic table gives you two values. So you, with these values, you segment them. Yeah. Okay, okay, ma'am. Okay. 1 o'clock we'll stop. Okay, fine. So the value will be, according to these values, you can break the range into this many. 1, 2, 3, 4, and 5. Right? So you have the calculated D value. You have the calculated D value. I've told you the formula. Right? If the value falls here, yeah. If the value falls here, if the D lies between 0 and DL, you will say there is a perfect autocorrelation. Perfect positive autocorrelation or positive correlation, significant positive autocorrelation. If the value, if your D lies here, you would say there is a significant positive autocorrelation. If the value is here, you will say, if the value is in the range, in this range, you will say there is a significant negative autocorrelation. If the value is in this range, between du and 4 minus du, you will say there is no autocorrelation. Right? If the value lies here or this range, you will say we cannot say anything. We cannot say anything. Right? So this is a very prominent Durbin-Watson test. Right? This is a very actually famous Durbin-Watson test, but it suffers from some assumptions. Right? Durbin-Watson is not very prominent, but it suffers from a lot of assumptions. Durbin-Watson can be applied only if the regression models include intercept term. Right? Non-intercept regression models, the Durbin-Watson cannot be applied. Right? If the autocorrelation is of order 1, first order autocorrelation alone can be tested using this Durbin-Watson test. Right? The regression model should not have any lagged dependent variables. Right? So these are all the prominent assumptions that make the applicability of this Durbin-Watson test very limited. Right? So people usually will go for the Bruce-Godfrey test because of this reason. But anyway, we will run both the things. Right? We will run the Durbin-Watson test and we will run the Bruce-Godfrey test. Right? And we will run the cure also. Right? I've told you 2 cures. One is this Pochner-Narkut. The other solution is robust standard error. Right? We will run it. Right? In the R. Right? So come back. Right? Actually at 2 o'clock we will do this work. Right? So we'll break for lunch.